Magandang araw sa inyong lahat. Ang magiging topic natin for today, it's solve problems in shunt generators. I'm going to present to you 16 problems later on na isosolve natin. Pero bago ang lahat, mag-establish muna tayo ng ating mga equations na gagamitin dun sa mga problem solving. Again, when it comes dun sa mga equations, hindi natin kinakailangang i-memorize ang mga yon. Pero kailangan lang natin gawin is understand how the circuit of the shunt generator works and ano yung mga involved na parameters dito. Para at least magiging simple yung ating buhay. Para yung importante kasi kapag gumagamit tayo ng mga equations, naiintindihan natin kung papaano sila gagamitin. Okay, so ang una muna natin gagawin, here we have the armature and then we have the brushes. Tapos alam natin na sa armature nandito yung generated EMF, tapos dito sa labas nandyan yung terminal natin, so terminal voltage ang makikita natin dyan. And here we have the armature circuit resistance, although alam natin na ang armature circuit resistance nandito yan sa loob ng armature mismo, but to simplify the solutions and computations, nilabas lang po natin yung armature resistance. And meron tayo dito yung shunt field resistance naman. So it is connected into parallel, kaya nga tawag natin dyan is shunt generator. Okay, ngayon naman yung direction ng mga kuryente natin. So yung sa armature current, siyang magpuproduce kasi or mag-generate ng kuryente. So ngayon, siyang panggagalingan ng ating kuryente. So here, we have the direction of our armature current. Ngayon, yung brush na ito will be positive and the brush here will be negative. Then for the resistance naman, yung positive and negative terminals niya, dahil nandito yung direction ng ating kuryente. So ang unang terminal, ito yung magiging positive. And then, yung next na terminal niya, that will be the negative. Yan. Ngayon, pagdating natin dito sa shunt field, ang magiging direction ng kuryente natin, dahil dadaan siya dito sa node na ito, ngayon, papasok yung IA dito, ngayon mahahati yan into two parts. Yung isa pupunta dito sa shunt field, and then yung isa naman pupunta dito sa terminal natin. So ngayon, dito, ito yung direction ng ating kuryente. Yan, and let's denote this as ISH. Yung sa iba, they're using IF, so field current, tapos ito naman RF, field resistance. Pero syempre, lagay lang natin dyan RSH and ISH. Yan. So ito yung magiging positive niya. Dahil ito yung unang dinaanan ng kuryente natin. So ngayon, itong terminal dito magiging negative dahil ito yung huling dinaanan ng ating kuryente. Pabalik dito sa ating armature. Next, dito naman sa terminal, which is isasaksak natin dito yung load. Mangyari, ito yung ating direction ng kuryente. Okay, papunta dito sa node na ito. Then, part of it pupunta dito sa load. And ito yung magiging direction ng ating kuryente dito. Okay, so let's denote this as IL, or this is the load current. Dahil dito nga natin isasaksak sa terminal natin yung ating mga loads. Okay, so mag-establish na tayo ng mga equations dahil nandito na yung ating mga parameters. Okay, so let us denote this as, that is node A. So, ang gagamitin na lang natin dito is the KCL or Kirchhoff's current law at node A. So, dito yon. So, again, when it comes to Kirchhoff's current law, pagdating sa tinatawag din natin itong nodal analysis, that is just the current in is equal to the current out, or the summation of current in is equal to the summation of current out. So, ang pumapasok na kuryente lang dito is sa node na A is IA. So, lagay natin dito is IA is equal to Ngayon, summation of current out. So from this node, dalawa ang lumalabas na currents natin. We have the IL and we have the ISH. So that is summation. So ibig sabihin, we have IL plus ISH. So yan po yung ating first equation. Next, establish naman natin yung iba't ibang equations pa dito by using Kirchhoff's voltage law naman. Ang una nating paglalagyan ng loop is dito. Okay, so let us denote this as loop number 1. Okay. So KVL at loop number 1. Okay, una muna natin. Again, by using Kirchhoff's voltage law, lahat ng dadaanan niya should have a unit of volts and ang kukunin natin ay yung huling sign na dadaanan ng ating loop. So ngayon, pagdating natin dito sa EG, negative yung unang terminal. So hindi ito yung negative yung kukunin, kundi yung positive dahil ito yung huling dinaanan ng ating loop. So we have positive EG. Again, take note na yung EG, voltage na ang kanyang unit. Ngayon, ang susunod na dadaanan ng loop is the RA. So, ang kukunin niya, negative sign. Okay, so minus. Ngayon, resistance, hindi ito volts. Para maging volts ito, kinakailangan natin ng current. Dahil voltage is equal to current times resistance. Okay, lalagyan natin dito is IA multiply this by RA. Yan. Next, dadaan dito yung ating loop. Ang dadaanan niya is the terminal voltage. Maglagay lang po tayo dito. This is the positive and then the negative. Okay, so ang sign niya is negative. So minus VT. Okay, so babalik na tayo sa EG. So lagi lang natin dito is equivalent to 0. So this is equation number 2. Yan. Next, let us have another loop. Dito naman tayo gumawa ng isang loop. Let us denote this as loop number 2. Yan. So KVL at loop number 2. Okay, so una muna we have, okay, dito dadaan yung loop natin. Meron tayo doong positive. So RSH, kinakailangan natin ng kuryente doon. So ngayon, ilagay lang natin. So positive ISH times RSH. Next, yung loop natin dadaan dito sa RA IA. Ngayon, that is also positive. So, positive. IA, RA. Next, dadaan siya dito sa EG. So, that is negative. So, minus EG equal to 0. So, this is going to be equation number 3. Okay, next, yung establish naman nating loop, magmumula dito sa ating, okay, sa terminal voltage, papunta doon sa pabalik niya, dadaan siya dito sa field natin. Okay, so, ito ang ating loop number 3. So, KVL at loop number 3. Ang unang dadaanan niya is the field resistance, so that is positive. So positive ISH, multiply that by RSH. Next, dadaan na siya dito sa terminal voltage, that is negative VT. So minus VT is equal to 0. So ngayon, this is equation number 4. Okay, tignan lang natin ng konti, no? Dahil dito, syempre yung voltage na makukuha natin dito is the VSH. And we know kapag yung sa according to Ohm's law, I is equal to V all over R. And pagdating natin dun sa relationship natin dito, we have, lagay lang natin dito, SH, shunt yan, and SH. Kaya makakakuha din tayo ng equation which is VSH is equal to, na itong RSH, lagyan lang natin dito sa, cross-multiply lang natin dito sa kabila. We're going to have ISH, RSH. Actually, yung property na ito, makukuha din natin dito sa equation number 4. Kasi connected into parallel yung ating shunt field and our terminal. Kaya nga, since they are connected into parallel, pareho sila ng voltage. Kaya dito, pwede nating ilagay yan na SH, wherein makukuha din natin ito. Okay, so let's start with our problem solving. So puntahan muna natin itong problem number 1. Okay, 240 volt shunt generator has a field circuit resistance of 150 ohms. What is the field current when the generator operates at rated voltage? Yan. So, lagyan lang natin dito. Ang tinutukoy niya, it is the voltage, or sorry, the field current, ISH ang hinahanap natin. Katulad ng formula natin kanina, we have ISH is equal to VSH all over RSH. So to get this one, VSH natin, okay, it is equivalent to the rated voltage. The rated voltage is 240 volts. So 240 volts, divide natin ito ngayon, RSH, which is 150 ohms. So check natin, 240 volts. 240 volts, divide that by 150. This is equivalent to 1.6 ampere. So, ito yung magiging sagot natin dyan. Next, let's go to problem number 2. Again, the question says, what is the field current of a 110 volt shunt generator if the field circuit resistance is 55 ohms? Again, ISH is equal to VSH all over RSH, or the shunt. So the shunt current, or the field current, is equal to the terminal voltage is 110 volts, which is equivalent also to the shunt voltage. So 110 volts po tayo doon. Divide this by 55 ohms. Therefore, ISH is equal to 110, divide that by 55 ohms will give us 2 amperes. Let's proceed to problem number 3. So a shunt field winding of a 240 volt generator has a resistance of 60 ohms. How much field rheostat resistance must be added to limit the field current to 3 amperes when the generator is operating at rated voltage? I-drawing lang natin ulit yung figure natin. Although meron siyang tinukoy dito na field rheostat. Yung field rheostat, katulad nung nakuha natin doon sa ibang topics, it is a variable resistance that is connected dito sa field winding para makakuha tayo ng variable resistance nang sa ganun makontrol natin yung field current. So meron tayo dito yung RSH. Ang RSH natin, that is given as 60 ohms. Next, here we have the terminal voltage. The terminal voltage is given as 240 volts. Tapos meron tayo dito yung sa may resistance para sa ating rheostat. Let us denote that as R. Okay, ang tinutukoy niya, ilang resistance daw yung idadagdag natin dito nang sa ganun malimit natin yung field current into 3 amperes. Kasi kung i-compute natin sa ngayon, like for example, yung resistance dito naka-zero, ang mangyari dyan, ISH is equal to VSH all over RSH. Again, yung VSH natin, since it is connected into shunt, equivalent siya to 240 volts. So, divide natin ito ng 60 ohms. Ang ISH natin is, so 240 divided by 60 ohms, that will give us 4 amperes. Ngunit sa problem kasi natin, kinakailangan nating ilimit yung field current to 3 amperes. So in order to do that, kinakailangan nating magdagdag ng resistance dito. Kung titignan natin yung circuit dito, this is connected into series and in parallel with the terminal voltage. Kaya pwede tayo maglagay dito ng computation. ISH is equal to VSH. Ngunit, yung sa resistance natin dito, that will give us the RSH plus R since they're connected into series. So we have RSH plus R. Okay. Ngayon, substitute natin yung mga given. Ang kinakailangan kasi natin dito is the ISH should be equivalent to or limited to 3 amperes. So, 3 amperes is equal to, yung VSH natin, still that is equivalent to 240 volts. Divide this by, so we have RSH is 60 ohms plus hinahanap natin yung R. So, cross-multiply lang po natin ito. Okay. Huwag muna tayong mag-shift solve para hindi ma-damage yung ating algebra. Okay. So, continue natin yung solution dito. So, nag-cross-multiply tayo. We're going to have 60 ohms plus R is equal to 240, okay, 240 volts, divide natin ito ng 3 amperes dahil cross-multiply natin doon. So we have 3 amperes. So una muna, tignan natin, i-check muna natin ito, 240, 240 divided by 3, that is equivalent to 80 ohms. Since that is volts all over amperes. So, dito tayo, 60 ohms plus R. Ngayon, gawin lang natin, sorry, that is, it's not 8, that is 80. Yan, 80 ohms, sorry. Ngayon, ito, transpose lang natin doon sa kabila. Magiging negative siya. That will give us R is equal to 80 ohms minus 60 ohms. Therefore, R is equal to 20 ohms. So, yun po yung sagot natin, 20 ohms. Next, let's proceed to problem number 4. I'm giving you 2 sets of each kind of problems. Sa ganun, mas makabisado natin yung ating subject. Okay? So, a 220 volt shunt generator has a field circuit resistance of 100 ohm. A field rheostat, again, is controlled in order to limit the field current to 2 amperes at rated voltage. How much resistance must be added using the field rheostat? I-drawing ulit natin yung ating diagram. So, andito yung field rheostat. Hahanapin ulit natin yung kanyang value. So, yung RSH natin is 100 ohms. Then, the terminal voltage is 220 volts. Again, titignan natin, no, kasi ililimit ulit natin siya into 2 amperes. Ngayon, kasi kung titignan natin yung ISH natin during the condition na wala tayong field or yung sa may field rheostat, yung value niya, so will give us VSH all over RSH. Ngayon, 220 volts, divide that by 100 ohms. Ang kuryente natin dito, okay, 220 over 100 is 2.2 amperes. Eh, kinakailangan natin daw i-limit into 2 amperes yung ating field current. Eh, dito sumobra siya ng 0.2. Ngayon, magdadagdag ulit tayo niyan. Ngayon, i-establish ulit natin yung ISH is equal to VSH all over RSH plus R. Hinahanap ulit natin yung ating R. So, ISH dapat natin is should be 2 amperes is equal to 220 volts. Divide that by 100 ohm yung RSH plus the resistance ito. Now, cross multiply ulit natin tong dalawang to. We're going to have 100 ohms plus R is equal to 220 volts divided by 2 amperes. So 220 divided by 2 amperes will give us 110. So 110 ohms, 100 ohms plus R. Again, transpose natin dun sa kabila yung ating 100 ohms, magiging negative. So that will give us R is equal to 110 ohms minus 100 ohms. This will give us 10 ohms na value na ilalagay natin dito sa ating resistance. So, ginagawa natin yung paglalagay ng rheostat dito, no, sa ating field circuit nang sa ganun makontrol natin yung kuryente dito. Kasi kung wala yung field resistance, yung computation niya palagi nandito lang po yan. Nakabase yung kuryente doon sa value ng resistance and yung terminal voltage natin. Ngayon, pwedeng magbago yung terminal voltage, nakadepende doon sa loadings natin. Pero, practically, kung gusto nating control yung ating system, kinakailangan nating maglagay ng field rheostat doon. Okay, but not all generators has the field rheostat. So let's proceed with the next problem, number 5. Okay, a 120 volt terminal voltage, 120 volt shunt generator has a field circuit resistance of 90 ohms. What is the armature current when the generator supplies 25 amperes to a load? Okay, drawing lang ulit natin yung ating figure. So, during this time, wala siyang field rheostat. Okay, next, yung terminal voltage natin, VT is equal to 120 volts. Ngayon, field resistance, this is 90 ohms. And ang sinasabi niya, what is the armature current? So, ang hinahanap po natin dito, it's the IA. Ang sabi niya dito, the generator supplies 25 amperes to a load. So, ibig sabihin yung 25 amperes na ito, yun yung kuryente natin dun sa load. That is our IL. So IL is equal to 25 amperes. Yan. So papaano natin kukunin ito? Okay, that is una muna, that is by the nodal analysis. So by nodal analysis, we have there the IA, katulad nung sa nakuha nating equation kanina, IA is equal to IL plus ISH. Okay. Para makuha natin yung ISH, kasi given na po yung ating IL doon, that is 25 amperes. Una muna, ISH is equal to VSH all over RSH. Again, the terminal voltage is equivalent to the shunt field voltage. So you have 120 volts, divide that by 90 ohms. So ISH is equal to 120 divide this by 90. That will give us 1.333 amperes. So, dire-diretsong 3 lang po yan. Yeah. Now, let's substitute this ISH dito po. Ngayon, we have IA is equal to, yung IL po natin, again, that is given as 25 amperes. Then, plus ISH, which is 1.333 amperes. Therefore, our IA is 26.333 amperes. So, ito po yung sagot natin dyan. Okay, so let's proceed with problem number 6, which is similar to problem number 5. Okay, so a 230 volt shunt generator delivers 50 amperes to a load. If the field circuit resistance is 115 ohms, what is the value of armature current? Again, drawing ulit natin yung circuit. We have the terminal voltage as 230. Then yung ating IL is equal to 50 amperes. Next, yung RSH natin is 115 ohms. So ang hinanap ulit natin po dito ay IA. Again, by nodal analysis po dito. So, we have IA is equal to IL plus ISH. So, given na yung IL natin, kinakailangan ulit natin hanapin yung ISH. ISH is equal to VSH. Again, that is equivalent to the terminal voltage. So, we have here 230 volts. Divide this by 115 ohms. So, this will give us 2 amperes. Yan. So, substitute natin doon. We're going to have IA is equal to 50 amperes plus 2 amperes. We're going to have 52 amperes. So, 52 amperes, mahati sa dalawa. We have 2 amperes and 50 amperes. Next, let's go to problem number 7. A shunt generator is rated 200 kilowatts at 240 volts. Letter A, what is the full load current? Letter B, what is the field current if the field circuit resistance is 100 ohms? Letter C, what is the full load armature current? So, unahin muna natin yung letter A. Ang hinahanap po kasi natin dyan is the full load current, or that is the IL. Yung given natin dito, we have 200 kilowatts Tapos, meron tayong 240. So, ibig sabihin po yung output niya is 200 kilowatts, 200,000 watts. We have the formula for that. P is equal to IV. So, cross-multiply lang po natin yung V, mapupunta dito sa baba. We're going to have the power output. Divide this by the terminal voltage. Ito na yung magiging formula natin for that one. Ngayon, the power is 200 kilowatts or 200,000 watts. Divide this by 240 volts. Compute lang po natin. So, 240,000 divide that by 240 volts. That will give us, that is 200. Okay. 200. Divide that by 240. Meron tayo ditong 833.333 amperes. Next, let's go to letter B. Letter B, what is the field current naman if the field circuit resistance is 100 ohms? So, field current, again, ISH is equal to VSH all over RSH. So, yung terminal voltage natin, which is equivalent to the shunt field voltage, is 240 volts. Divide this by 100 ohms. This will give us 2.4 amperes. Now, let's go to letter C. Ang hinahanap natin is the full load armature current. So, the full load armature current is IA is equal to IL plus ISH. So, that is 833.333 amperes plus 2.4 amperes. So, makukuha natin dito, it's 835.733 amperes. That is for the armature current. Okay, let's proceed with problem number 8. So it is again similar to problem number 7. So 150 kilowatt, 220 volt shunt generator has a field circuit resistance of 150 ohms. Determine the value of the full load current, field current, and armature current at full load. Okay, pag sinabi niyang full load, nagagamit natin lahat-lahat yung 150 kilowatts doon. Again, IL, power output, divide this by VT. The power output is given as 150,000 watts. Divide that by 220 volts. So, compute natin. That is 150,000. Divide this by 220 volts. That will give us 681.818 amperes. Next, ISH, we have VSH all over RSH. So, VSH natin equal to terminal voltage 220 volts. Divide that by 150 ohms. So, 220, divide this by 150. It will give us 1.467 amperes. And then for the armature current, IA is equal to IL plus ISH. So IL natin is 681.818 amperes plus 1.467 amperes. Gumagamit ako ng 3 decimal places, no? Kasi mas magiging accurate tayo. Mas nearly to truth yung computation natin. 681.818 plus 1.467. This will give us 683.285 amperes. Now, if you are more comfortable using 2 decimal places, so that is just okay. Pero sa akin kasi mas okay ako dun sa 3 decimal places. Dahil yung error niya mas nagiging mas konti na. Okay, let's proceed to problem number 9. So, problem number 9. Yan, sabi niya dito, the terminal voltage of a shunt generator is 115 volts when the generated EMF is 119. 119, hindi po yan 198, kundi 119 volts and the armature current is 20 amperes. So, ang hinanap natin, what is the armature circuit resistance? So, drawing lang po ulit natin yung ating diagram. Yan. Sa problem na ito, no, kahit wala nang given yung sa RSH, kasi nga ang hinanap naman natin yung sa RA, ngayon, makukuha lang po natin yan dito sa loop number 1 na ang dadaanan lang po niya is the generated EMF, the IARA, tapos yung ating terminal voltage which is already sufficient dun na nakikita natin sa problem yung ating mga given. The terminal voltage, VT is equal to 115 volts. Then, yung generated EMF niya is given as, EG is given as 119 volts. So, ngayon yung IA natin dyan, IA, this is equivalent to 20 amperes. Ang hinahanap natin is the armature circuit resistance. Ngayon, yung sa loop natin dito, okay, establish muna natin yung positive dito sa EG and negative dito naman sa ating RA, yung positive niya dahil nandito yung unang nadaanan ng ating kuryente. So, ito na yung maging positive. Yung nahuli, yun yung maging positive. So, dito sa terminal voltage, ito yung nauna niyang dinaanan, yung kuryente. So, ito yung ating positive. Tapos, pagdating dito, that is the negative. Again, yung establish natin yung loop natin dito. Okay? So, let's say that is loop number 1. So, KVL at loop number 1, that will give us, again, positive EG. So, positive EG. Then, next, negative. So, yung RA ang dinaanan, kinakailangan natin magdagdag ng, multiply tayo ng kuryente, IA, RA. Next, ang dadaanan niya dito is the VT. So, negative po yun. So, negative VT is equal to 0 dahil babalik na tayo sa EG. Okay, so, ang hinanap natin is the armature resistance. Ngayon, ang gawin natin muna, itong parameter na ito, lagyan natin dito sa kabila. So, magiging positive po yan. Okay, so ang maiwan dito is the EG and then the VT. So, dito, EG minus the terminal voltage is equal to, maging positive po ito. So, IARA. Yan po. Ngayon, EG is equal to 119 volts. 119 volts minus a terminal voltage which is 115 volts. 115 volts is equal to, yung IA po natin, it's given as 20 amperes. Then, multiply that by RA. Yan. Ngayon, pwede nating i-divide both sides by 20 amperes. So, 20 amperes. So, cancel out na dito. Ang maiwan po dito is the RA. So, RA. Ngayon, tignan natin. 119 119 minus 115, that will give us 4 volts divided by 20 amperes. This will give us 0.2 ohms. So, yon po yung ating sagot, 0.2 ohms. Let's go to problem number 10. Here we have the generated EMF of a 240 volt generator is 255 when the armature current is 50 amperes. So determine the armature circuit resistance. Yung from the problem natin kanina dito sa problem number 9, ito yung kukunin ulit nating equation. So that is EG minus IARA minus VT is equal to 0. Yan. So, ang hinanap natin ulit ay the armature circuit resistance. Again, ito transpose natin sa kabila, magiging positive po yun. So, EG minus VT is equal to positive IARA. Yan. EG is given as 255 volts minus the terminal voltage is 240 volts is equal to 50 amperes. Multiply this by RA. Again, divide both sides by 50 amperes. Cancel out na po yan. So, 50 amperes. Now, this is 255 minus 240. That will give us 15. Divide that by 50 amperes. RA is 0.3 ohms. So, yan po yung ating sagot. Next, let's go to problem number 11. The terminal voltage of a 75 kilowatt shunt generator is 600 volts at rated load. The resistance of the shunt field circuit is 150 ohms and the armature circuit resistance is 0.1 ohm. Determine the generated EMF. So, drawing ulit natin po. Ito, medyo mas magagamit na po natin halos lahat ng ating mga parameters. Yan. So, the terminal voltage is given as 600 volts. The power output, PO, is equal to 75 kilowatts. Now, yung armature circuit resistance natin is 0.1 ohm, 0.1 ohm. And we have the field resistance is 150 ohms. Yan. Ang hinahanap po natin dito is the generated EMF, that is EG. Yan. So, establish lang po natin yung positive and then the negative. Positive, negative, positive, negative, positive, and negative. So, in order to determine EG, puntahan po natin yung loop natin dito, that is loop number 1. So, lagay lang po natin dito. KVL at loop 1. Again, that is positive EG. Positive EG. So, minus. So, meron tayo ditong IA. Ngayon, minus IARA. Then next, minus VT. Minus VT is equal to 0. Ngayon, yung terminal voltage natin is already given. Yung IA natin, so wala ito. So, RA is meron. So, ibig sabihin, kukunin natin yung ating IA. In order to get the value of IA sa isa pang equation, we need to establish an equation dito sa node A. So, mag-KCL tayo dito. KCL at node A. Again, yung KCL na nahanap natin kanina dito, dahil dito meron tayong ISH. So ngayon, summation of current in is equal to the summation of current out. So, meron tayo ditong IL. Next, so we have there, again, summation of current in, ang pumapasok lang po dito is IA. Then, yung lumalabas sa kuryente naman dito is equal to IL plus ISH. So, IL plus ISH. Ngayon, wala pa tayong IL, so kinakailangan din nating hanapin ito. Wala pa tayong value ng ISH, so kinakailangan din nating hanapin ito. So, from our previous problems, IL is equal to PO over VT. So, yung power output natin is 75,000 watts divided by 600 volts. So, yung value ng ating IL, 75,000, divide that by 600 volts will give us 125 ampere. So, solve na tayo dito. Ngayon naman, kunin natin itong ISH. Again, ISH is equal to VSH all over RSH. So, dito, we have 600 volts divided by 150 ohms. Therefore, ISH is equal to 600 volts divided by 150 will give us 4 amperes. Yan. So, pwede na natin mahanap ngayon yung IA. That is IL, 125 plus 4 amperes. So, IA is equal to 125 amperes plus 4 amperes. This will give us 129 amperes. Yan. Ngayon, itong IA na ito, pwede na natin siyang ilagay dito in order to determine what is EG. So, ito, yung dalawang to, transpose lang po natin sa kabila, magiging positive po silang dalawa. So, from this equation, we're going to get EG is equal to VT plus IA RA. Yan. So, inuna lang po natin, no? Pinagbaliktad lang po natin, pero pareho lang din po yon. Ngayon, VT is given as 600 volts plus yung IA natin is 129 amperes. Multiply this by 0.1 ohm. Therefore, EG is 600 plus 129 plus point and multiply that by 0.1 will give us 612.9 volts. Yan po. Okay, so let's proceed with the problem number 12. Ngayon, a 100 kilowatt 220 volt shunt generator has an armature circuit resistance of 0.15 and a shunt field circuit resistance of 200 ohms. So determine the generated EMF at full load. Again, drawing lang po ulit natin yung ating diagram. The terminal voltage is given as 220 volts. And the power output is equal to 100 kilowatts. Now, RA is given as 0.15 ohms, wherein the shunt field resistance is 200 ohms. So, ang hinahanap po natin is the generated EMF. So, ulitin lang po natin yung problem, yung principle na natutunan natin kanina. Again, we have here the IA. Next, we will establish our loop here, loop number 1. So, KVL at loop number 1, we have, again, positive EG minus IARA, then next minus VT is equal to 0. So, again, given na po yung VT natin, given na rin po yung ating RA, which is 0.15, hahanapin natin po yung ating IA. So, for IA, again, we have here the IL, tapos dito naman po, we have the ISH. So, let's establish this again. Denote that as node A. So, again, KCL at node A, we have IA, summation of current in, is equal to summation of current out. IA is equal to IL plus ISH. Again, kinakailangan din po natin hanapin yung IL and kinakailangan din po natin hanapin yung ISH to get IA. Yung IL po natin, we have 100 kilowatts divided by 220 volts. So, check lang po natin. We have 100,000 divided by 220 volts will give us 454.545 amperes. So 454.545 amperes. Next, let's determine what is ISH. ISH is equal to VSH all over RSH. So this is equivalent to 220 volts divided by 200 ohms. Therefore, ISH is equal to 220 divided by 200, that is 1.1 amperes. Next, let's determine IA using this equation. IL is 454.545 amperes plus 1.1 amperes. So, IA is equal to, we're going to have 455.645 amperes. Again, from this equation, transpose ulit po natin itong dalawang to dito sa kabila, maging positive po sila. EG, therefore, is equal to VT plus IARA. Therefore, EG, terminal voltage is 220 volts plus the IA is 455.645 amperes, multiply that by 0.15 ohms. Therefore, EG is equal to 0.15 plus 200, okay. We are going to have 228.347 volts. Yan po. Sorry, it should be 288, not 228. Yan. Oh, let's verify na muna. Okay, so 288.347 volts. Let's go to problem number 13. So for problem number 13, we have a 100 kilowatt, 220 volt shunt generator, has an armature circuit resistance of 0.15 ohm and a shunt field circuit resistance of 200 ohms. Determine the generated EMF at half load. So, half load naman po yung pinag-uusapan po natin dito. because we will be encountering several problems na meron tayong hindi niya ginagamit yung buong power output niya. Okay, the terminal voltage is given as 220 volts. The power output is 100 kilowatts. Ngunit ang sinasabi po niya, half load. So ibig sabihin kapag half load po yan, divide lang po natin ito ng 2. We're going to have 50 kilowatts lang po yung gagamitin ng ating system. So instead of using the 100 kilowatts doon. So yung RA is 0.15 ohms. Ngayon naman, again, dito, similar lang po ito dun sa problem number 13 natin. Ngunit, ang hinanap natin ngayon is the half load. So wala siyang tinukoy about the terminal voltage. So let's assume na yung terminal voltage niya, 220 volts pa rin. Dahil sa principle ng generator, habang nagdadagdag tayo o nagbabawas tayo ng load, nagbabago yung terminal voltage. But for this problem, because it is not being said, kaya ang gagamitin pa rin nating terminal voltage is 220 volts. So ang hinanap pa rin po natin dyan is the generated EMF, EG. Yan. So establish ulit natin yung positive, negative. Positive, negative, positive, negative. Nandito po yung ating IA. Andito yung ating IL, andito naman po yung ating ISH. So, again, let's have a Kirchhoff's voltage law at loop number 1. That is again the positive EG minus IARA, then minus VT. Is equal to 0. Again, given na yung terminal voltage, given na yung RA, ang hahanapin natin is the IA. So, using node A, so Kirchhoff's current law at node A, we're going to have IA equals IL plus ISH. Again, nagbago tayo ng PO kanina. Instead of using 100 kilowatts, gagamitin lang po natin yan is 50,000 watts divided by 220 volts. So, IL 50,000 divided by 220 volts. So, meron lang tayo ditong 227.273 amperes. We are in yung ISH naman. So, ito naman kunin natin. Again, we have VSH all over RSH. We have 220 volts divided by 200 ohms. Still, ang kuryente natin dito is 1.1 ampere. Therefore, substitute natin yung IL and ISH dito. We have IA is equivalent to 227.273 amperes plus 1.1 amperes. So will give us IA is equal to 228.373 amperes. Yan po yung IA natin. Now, let's proceed in solving the EG. Again, from this equation, ulit, yung parameters na ito, lagay po natin dito sa kabila, maging positive po sila. VT plus IARA. So, therefore, EG is equal to, VT is 220 volts plus IA is 228.373 amperes. Then, multiply lang po natin ito ng 0.15 ohms. So, 220 plus 228.373 times 0.15 15, 220 volts plus 228.373 times 0.15. We have 254.256 volts. Yan po. So compare lang po natin dun sa number 13 kanina, no? Since dito sa number 13, full load po ang ginamit natin, yung 100 kilowatts. Therefore, yung kanyang generated EMF is 288.347 volts. Mas mababa po yung generated EMF kapag half load lang po tayo. Pero yung terminal voltage natin, nag-assume tayo na they are both equal in both situation. Ngayon lang po, ang nangyari po kasi dyan, yes, pwede po nating ma-maintain yung terminal voltage ng mga generators natin. Ngunit, habang nagdadagdag po tayo ng load, ang nangyari po doon, tumataas po dapat yung ating generated EMF. Dahil ngayong kinakailangan niyang mag-deliver ng sapat na power output, yung mga kilowatt output niya, doon sa ating mga loads. Kaya po, kapag magbabawas pa po tayo ng load, sigurado po, bababa po yung value ng generated EMF natin. So nagbabago-bago yung value ng generated EMF natin. Nakadepende po kung gaano kadami yung sinasaksak nating loads dun sa ating mga generators. It is just the same when it comes to alternators and DC generators. Now let's proceed with problem number 14. Okay, so 3 problems na lang po. Okay, so a 60 kilowatt 240 volt shunt generator has an armature and field circuit resistance of 0.18 ohm and 100 ohm respectively. Determine the generated EMF if this machine is delivering 1/3 of its rated capacity at rated voltage. So, drawing ulit natin yung diagram. Ang sinasabi niya dito sa problem natin, instead of having a full load, meron lang po tayong 1/3 of its capacity. So, mas mababa po pa yan compared doon sa half load, yung sa problem number 13 natin. Okay, dito sa power output natin, so 1/3 lang po ito, 1/3 ng 60 kilowatts. So, this will just give us, okay, 1/3 neto is 20 kilowatts. Again, that terminal voltage pa rin natin is rated voltage, no? So that is 240 volts. Next, the armature circuit resistance is 0.18 ohm and 100 ohms po tayo dito sa RSH. So ang hinahanap po pa rin natin dito is the generated EMF. So let's establish the positive and the negative. Positive, negative. So, meron tayo ditong IL, andito yung ating IA, tapos nandito po yung ating ISH. Again, in order to determine the generated EMF, we have KVL at loop number 1. Okay, that is again EG minus, so for sure, kabisado na po natin ngayon yung ating equation. Okay, again, given yung VT, given yung RA, hahanapin natin yung IA. In order to do that, let's have Kirchhoff's current law at node A, which is IA is equal to IL plus ISH. Next, kunin natin muna yung IL and ISH. So for the IL, we have 20 kilowatts, divide this by 240 volts. So IL, 240,000, divide that by 240, that is only 20,000. Divide that by 240. So we have here 83.333 amperes. Wherein our ISH is VSH over RSH. So, bibigyan niya tayo dito ng 240 volts. Divide this by 100 ohms. So ISH natin is 2.4 amperes. Therefore, substitute natin yung values ng IL and ISH dito. So IA therefore is 83.333 amperes plus 2.4 amperes. This will give us 85.733 amperes na pwede na nating i-substitute dito. Again, transpose lang po natin itong dalawa. Sa kabila, maging positive sila. VT plus IARA. So EG is equal to, we have there 240 volts plus 85.733 amperes. Multiply this by 0.18 ohms. Therefore, the generated EMF is 240 plus 85.733 times 0.18 ohms. This will give us 255.432 volts. Yan po. 2 problems na lang po. Let's just be patient. So this is a different type of problem. Okay, number 15. In a 50 kilowatt 250 volt shunt generator, 258 volts are generated in the armature when the generator delivers rated load at rated voltage. So the shunt field current is 4 amperes. Determine the resistance of the armature. So ang hinahanap naman po natin dito is the RA, the armature circuit resistance. Again, establish po natin yung ating diagram. We have here the EG. EG, ang EG natin given na siya as 258 volts. Wherein our terminal voltage is given as 250 volts. The power output is equivalent to 50 kilowatts. Ngayon, yung field current natin, the shunt field current, ISH, okay, wala siyang given na RSH, although meron tayong given as the shunt field current, that is 4 amperes. So kung gusto yung kunin yung RSH, pwede naman. That is only 250 volts divided by 4 amperes. Okay, pero dito sa problem, hindi na natin kinakailangan makuha yon. Okay, or hindi na natin kinakailangan kunin yon. So, lagyan lang natin, no, yung we have the RA here. Ito po yung hinahanap natin. Ngayon, establish ulit natin yung positive, negative, positive, negative, positive, and negative. Una muna, no, that is by KVL at loop 1. So, KVL at loop number 1. So, ito yung loop number 1 natin. Again, we have positive EG. Positive EG minus IARA minus VT is equal to 0. Yan. Given na po yung ating VT. Given din po yung ating EG. Ang hinahanap po natin is the RA. Ngunit this time, wala pa po tayong IA. So, pwede po natin makuha yung IA. Okay. So, kunin po natin siya. Mag-denote ulit tayo dito ng node A. So, Kirchhoff's current law at node A. So, that is IA is equal to IL plus ISH. Pulit tayo. So, pwede natin makuha yung IL. Given na po yung ating ISH, makukuha natin yung IA. Substitute lang po natin dito. Sigurado makukuha na natin yung RA. So for IL, again, that is the power output divided by the terminal voltage. 50,000 watts po tayo dito. Divided by 250 volts. So IL, 1, 2, 3, divide this by 250. Sorry. Okay, so this will give us 200 amperes. So, pwede na natin i-substitute dito sa equation ng IA dahil given naman na po yung ating ISH as 4 amperes. So, 200 amperes plus 4 amperes, IA is going to be 204 amperes na pwede na natin pong i-substitute dito. So, ang gawin po natin, itong IARA, transpose lang po natin dun sa kabila. So, magiging positive po yon. Ang matiiwan po, EG and VT. So, from that equation, EG minus VT is equal to positive IARA. Yan po. So, yung EG natin, that is given as 258 volts minus 250 volts equals 204 amperes, multiply that by RA. So, divide lang po natin both sides by 204 amperes. Cancel out na po doon. Dito rin, divide that by 204 amperes. So, RA, that is 8 volts. So, this is 8 volts divided by 204 will give us 0.0392, or this is approximately equivalent to 0.04 ohms. So, yun po yung ating sagot. Approximately 0.04 ohms. So, let's proceed with our last problem, which is similar to problem number 15. Yan. So, 250 kilowatt, 440 volt shunt generator generates 450 volts in the armature when delivering its rated capacity. The field circuit resistance is 70 ohms. Okay, 70 po yun. Determine the resistance of the armature. And let's have our diagram. Yung kanina, field current ang given. Ngayon naman po, ang given sa kanya, it's the field circuit resistance, that is 70 ohms. Next, the terminal voltage is 440 volts. Okay, that is VT. While EG is equal to 450 volts. Ang hinanap po natin dito again, it's the RA. Yung power output natin dito is 250 kilowatts. Again, we have here the IA, tapos nandito po yung IL. Hopefully, nakakabisado na po nating lahat to. So, we have here the ISH. So, in order to determine that, mag-establish tayo ng loop number 1 po dito. Again, KVL at loop number 1, we have positive, negative po dito. Kalimutan natin ilagay na muna to. Okay, so positive, negative. Again, so positive EG minus IARA minus VT, okay, equal to 0. So again, given na po yung terminal voltage, 440 volts, given din po yung EG. Ang hinanap po natin yung RA, ngunit wala pa po tayong given na IA na pwede nating makuha. Establish ulit tayo dito ng node, okay, KCL at node A. Again, that is IA, summation of current in and summation of current out. IL plus ISH. Kunin po natin yung IA, yung load current, that is PO over VT, that is 250 kilowatts, or that is 250,000 watts divided by 440 volts. So 250,000, 1, 2, 3, divide this by 440 volts. So this is given as IL is equal to 568.182 amperes. Yan. Next, hanapin naman po natin yung ating ISH kasi nahanap na natin yung IL. So ISH is equal to VSH all over RSH, which is 440 volts divided by 70 ohms. So 440 divided by 70 will give us 6.286 amperes. Now, let's go. Substitute natin dito. Okay, IA is equal to 568.182 plus 6.286. So, unit natin dito ay amperes. So, 568.182 plus 6.286 will give us 574.468 amperes. So, pwede na natin i-substitute dito. Again, ito, transpose ulit natin sa kabila. We're going to have EG minus VT is equal to IARA. Okay, so EG natin, that is 450 volts minus 440 volts is equal to, okay, yung IA natin is 574.468 amperes. Multiply that by RA. So, compute lang natin. 450 minus 440, that will give us 10 volts. So, 10 divided by 574. So, this will give us 574.468. This will give us 0.017, or this is approximately equivalent to 0.02 ohms. So, yun po. Yan. So, sana may natutunan tayo ngayong araw na ito. Maraming salamat po.